Let the random variable x be the number of vowels in a random selection of 4 letters from those in the word logarithm, with no letter to be chosen more than once. Complete the probability distribution of x below. So we know that these have to add up to 1. So all we're going to do here is 1 take away 5 over 42, take away 10 over 21, take away 1 over 21. And that gives us 5 over 14. Show how the probability for x equals 1 was calculated. Well, if we count the letters here, there's 9 letters. 3 are vowels, and that means we've got 6 consonants. So from the 3 vowels, we must have chosen 1. From the 6 consonants, we had to choose 3. So if we do 3C1 multiplied by 6C3, that's the number of different selections of 4 letters that contain 1 vowel. And we need to divide that by the total number of selections of 4 letters. So that is going to be 3 choose 1. You might have known that was just 3. And 6, 3, and divide that by 9, 4, and that gives us 10 over 21. Determine the probability that x is greater than or equal to 1 given that x is less than or equal to 2. We're using the formula that x is greater than or equal to 1 and x is less than or equal to 2 divided by the probability that x is less than or equal to 2. So the top here is just x being 1 or x being 2, so that's going to be 10 over 21, add 5 over 14. X is less than or equal to is everything but this one, so that's clearly going to be 20 over 21, and we just need to then calculate that. So let's go back here, and we want a fraction. We're going to need fractions on top of that fraction, so that's 10 over 21, add 5 over 14, and divide that by 20 over 21 is 7/8. Let event A occur when no vowels are chosen in a random selection of 4 letters from those in the word logarithm. State the probability of not A. Well, probability of A is 5 over 42. So that's just going to be 1 take away 5 over 42. So 42 take away 5 is 37, so that's going to be 37 out of 42. Let y be a Bernoulli random variable with parameter p equal to p of a. Determine the mean and standard deviation of y. Well, for a Bernoulli, we know that the expectation is just equal to p, which was 5 over 42. The standard deviation is, as always, the square root of the variance, and for a Bernoulli that's PQ, so that's going to be 5 over 42 multiplied by 37 over 42. So we'll just calculate that. So square root of 5 over 42 multiplied by 37 out of 42. I suspect in standard mode it's not going to make much of that. Oh, it's done it. So that's root 185 out of 42, and it might be best just to give that one as a decimal. So 0.3238 would work nicely there. Determine the probability that A occurs no more than twice in 10 random selections of 4 letters from those in the word logarithm. Now remember, A is getting no selections, so the probability of that was 5 out of 42. So 5 out of 42. And we're taking 10 selections. Clearly we're making this into a binomial. So let's call this Q or something. Q is a binomial. And no more than twice, so we're after the probability that Q is less than or equal to 2. So we'll go for a distribution, discrete binomial CDF, going from 0 to 2 with 10 trials. Probability of success is 5 out of 42, and that gives us 0.8933.